Okay, so I hope you can see me. And if you're staring at my house, I'm trying, I don't know. For some reason, my phone, when I'm videoing, it won't let me like flip the camera back and forth, which is crazy annoying, but okay. You are going to need a small piece of the test back questions and your math notebook. So I'm just going to show my math notebook and I'm going to talk so it's not weird. Please make sure that you're writing down what I'm writing down. Please make sure that you're paying attention because I don't want to lose a whole day. It would kill me. So here's my math notebook. I'm going to flip. You can get this little test spec questions paper from Miss Adriana. It is all the questions I've seen them ask about the powers of 10 with exponents types of questions. So I want to practice those things so that, we know what to do. So eventually you'll end up gluing this on a piece of paper and then our notes, because I know this is really tiny. So our notes will be here, but our notes will also be right next to it. So if you are not like let's say you ended here and then you have this page blank, go ahead and say that you'll glue it here and then you'll write on the very next page. But that's just not where my notebook is. So I'll be here. All right. The first type of test spec question says, what is the value of 10 to the second power? There we go. I want to remind you, and I want you to write this down too, so don't just watch it. Pick up your pencil. 10 to the second power is not 10 times 2. It's 10 2 times, so 10 times 10. What's so great about these exponents is that it's just a 1 and some zeros. That's it. So 1 times 1 is 1. There are 2 zeros there, which tells me that 10 to the second power, or 10 times 10, is just equal to 100. What I want you to realize is they've got a bunch of trick answers here. So they're saying that your options could just be 10, 12, which means that you would have added 10 and 2, 20, which means that you are multiplying 10 times 2, and then the actual answer of 100. What I need you to realize is that whatever the base is, you need to use that base however many times the exponent tells you. So 10 to the second power is not 10 times 2, it's just 10 times 10. We've worked on this, okay? It says, what is 0.523 or 0 and 523 thousandths times 10 to the second power? If you are like, I don't know, then you find what you need. Let's see, can I zoom? Here we go. Times 10 to the second power, you're moving right because you're multiplying, and that little exponent tells you to move 2 times. Guys, it's the same thing that we've been doing, okay? So if this 10 to the second power, or times 10 to the second power rather, tells me to move right 2 times, then you need to pick up that decimal point and you need to move 2 times to the right. So we still have a 0, a 5, a 2, and a 3, but now, now I've moved it from right in front of the 5 to right behind the 2. All you're doing is solving it. Not a big deal. This third thing here says, what is the value of the missing exponent in the expression? I'm going to say that this is number 3, and then we're going to do a bullet point that says steps to solve number 3. All we are doing is counting loops. That's it. I want to get, let me see here. I don't want to miss something. Hang on. There we go. I guess it doesn't matter. Okay. What is the value of the missing exponent in the expression 523 divided by 10 to some power, so that's a question mark, would give me 52 and 3/10? If you can see these numbers, 523, 52 and 3/10, they look very similar. They're supposed to. I'm going to write those two numbers down. 523 has no decimal point, so I'm going to stick it in the back. And then my other number was 52.3. Now, I can see that the decimal would be behind the last number, or you can just say the decimal is between the 2 and the 3. So I want the numbers to match. If I can see that the decimal is at the very back because there was no decimal, I want to put another decimal at the very back. And then for the millionth time, you guys, we are making a loop. That's it. So however many loops it's going to take you to get from one decimal point to the other, that's what the missing exponent is. So if I have a decimal behind the 3, and I put another one behind the 3, and I'm only making one loop, then that means my missing exponent is just 1. I want to practice because I want to make sure we get this, because this could be such an easy point for you. You're making loops still. Let's say we have 97.8, and I'm expecting you to write this down too. It's not just me. If I'm writing it, you're writing it. 97.8 divided by 10 to some power is going to give me 0.0978. The numbers are supposed to look similar. I'm going to put the numbers right next to each other so I can see them. I can see in this first number, first off, I want to say if at any point I'm ever going too fast, I'm writing too fast, just pause it so you can write down what you need, because I am expecting you to write this down too. In this first number, my decimal is right behind the 7, right in front of the 8, right between the 7 and the 8. So I'm going to make the numbers match. I'm going to make the decimals match. We are making loops from one decimal point to the other. If I have made 1, 2, 3 loops, that means that your missing exponent is 3. I'm going to do one more because you're going to have to solve something like this on your own when the video's done. So let's say we have 104 and 5/10, so 104.5, divided by 10 to some power is going to give me 1 and 45 thousandths, 1.045. I'm going to write the numbers right next to each other just so it's a little bit easier for me to see it. I can see in my first number that I have a decimal right behind the 4, right in front of the 5. So I'm going to put another one right behind the 4, right in front of the 5. And we are making loops from one decimal point to the other. You're making the decimals match. However many loops you've made, I've made 2, then that's what your missing exponent is going to be. What's so great is we're still just making and counting loops. That's it. We're going to have one that's just like this at the very end. So just like an exit ticket. So make sure you know what we're doing. We're just making and counting loops. You find where the decimal is and you make the decimal points match. And then you're making loops from one decimal point to the other. However many loops you make, that's what your missing exponent's going to be. I made 1 loop, my missing exponent was 1. I've made 3 loops, my missing exponent is 3. I've made 2 loops, I'm just going to make a line here, then my missing exponent is 2. That's it. My following question says, which statement is equivalent? And equivalent is just a fancy word for equal, if you want to write that down, to multiplying a number by 10 to the 3rd power. The big thing here is that is not 10 times 3, it's 10 3 times. The exponent tells you how many times to use the base as a repeated factor. Now, what's great is they have 2 terrible answers, so you can get rid of 2 right off the bat. Anytime they're talking about exponents, you are never adding, we're multiplying. So if it says adding, cross it out. Get rid of it. It's not your option. 10 3 times looks like 10 times 10 times 10. So you have two answer choices here. C says multiplying by 10 3 times. D says multiplying by 3 10 times. It should be C, because multiplying by 3 10 times would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But they're two totally different numbers, because this over here is 1 times 1, which is 1, 1 times 1, which is 1, and 1, 2, 3 zeros. Oops, I'm running out of room. There we go. 1,000. This would be way bigger, because 3 times 3 is 9. 9 times 3 is 27. You would do 27 times 3. Whatever that is times 3. Whatever that is times 3. But you're not going to end up with 1,000. What I need you to realize is whatever the exponent is, so this was a little 3, it tells us how many times to use that base, that 10, as a repeated factor. So 10 to the third power simply means multiplying by 10 3 times. It's just 10 times 10 times 10. When dividing a number by 10 to the third power, how is the decimal point moved? Well, this is what dividing is, okay? So if you have no idea, you go back, get your little orange sticky note, and you find dividing by 10 to the third power. Anytime you're dividing, you are making the number smaller. And if you are making the number smaller, you need to be moving to the left. We would be moving 3 times because that little exponent is 3. It's telling you to move 3 times. Hang on, I'm stuck. Here we go. If you're dividing, we're going left, always. Multiplication, we're moving right, unless we're multiplying by a fraction. Anytime we're dividing, we're always going left. Because this little exponent here is 3, there we go, we're moving 3 times. So right off the bat, if this exponent is 3, I know for sure I can get rid of C and D because they're asking me to move 4 times. But my exponent's not 4, my exponent's 3, so they're gone. Dividing is left, so 3 places to the left, you're done. This really is the hardest type of test spec question because you actually have to move the decimals and see if things match. So I'm going to walk you through it. It says, Mrs. Violante, Mrs. Nickerson, and Mr. Ballinger multiply and divide original numbers by a powers of 10 to create new numbers. So here's a list of original numbers. Here's a list of new numbers. Which original numbers were multiplied by 10 to the third power to create the new numbers? Multiplied, multiplication. They're asking you, where are you multiplying by 10 to the third power to get the new number? But I want to remind you, if you are multiplying by 10 to the third power, you are moving right 3 times. Multiplying, we're moving right. Exponents 3, we're moving 3 times. This means that you're going to have to try everything because it's a select all question, even though it doesn't say it's a select all question. There is more than one right answer. You're going to have to move the decimal point for each one of these original numbers and see if it matches your new number. And if it matches, we'll mark it off, and if it doesn't, we'll leave it. Because this is 422, it's a whole number and there is no decimal point, I want you to start by putting a decimal point at the back. Guys, they want us to multiply. They want us to move right. Your exponent is 3. We're moving 3 times to the right. The right's going this way. So I'm going to move 1, 2, 3 times. I have 3 extra empty loops. And the only number you can put in an extra empty loop is a 0. That's it. Your next step is to figure out, are these numbers now the same number? This new number over here says 422,000. But again, there's no decimal point. So you'd have to stick it at the back. So you look and you see there's a 4, a 2, a 2, and then you moved that decimal point. So you have a 0, and a 0. You move that decimal point to the end. This had no decimal point, so the decimal point is at the end. But that tells me that these things are exactly the same. They match. And because they match, that means that this should be one of our answer choices. We're going to keep doing that all the way through this table. We are multiplying, moving right, by 10 to the third power. That little exponent is 3. So I'm going to pick up the decimal because this one has a decimal. And I'm going to move 1, 2, 3 times to the right. This is going to be 0, 0, 0, 5 decimal point. Now, oddly enough, you guys, these numbers, as weird as this one looks, this number is still just 5. There is a 5 in the ones place. There's nothing in the tens place. Nothing in the hundreds place. Nothing in the thousands place. So this number is still just 5. This also shows 5. No decimal. You're sticking it at the back. As weird as this looks, these things do match 100%. They're the same number. But because they're the same number, we need to mark it off in our answer. There's going to be more than one right answer. It's a select all question. This is 200. We are multiplying, moving right, by 10 to the third power, which means we're moving right 3 times. Any extra loop gets a 0. Now, in my new number, this shows me having a decimal point right in front of the 2. I did not end up right in front of the 2. So because the decimal is not in the same spot, it's not going to work for me. Doesn't match. You're not marking through it. Just leave it. It's blank. Don't touch this. It's not going to work. 400 is a whole number. No decimals. Stick it at the back. We are multiplying by 10 to the third. We're moving right 3 times. I'm picking this up and moving 1, 2, 3 times to the right. Extra loop, extra 0. Extra loop, extra 0. Extra loop, extra 0. And you see if they match. I have a 4 and a 4, a 0 and a 0, a 0 and a 0, a 0 and a 0, a 0 and a 0. But if you count, this is 1, 2, 3, 4, 5 zeros, and 1, 2, 3, only 4 zeros. And they're not the same because they don't have the same number of zeros. This number is 400,000. This number is only 40,000. But because they don't match, you don't touch it, you leave it, it's not going to work. I have a decimal point here, 4.556. We pick it up and we're moving 3 times to the right because we're multiplying by 10 to the third power. This has me ending up right behind the 6. If you look at the new number, the decimal is in front of the 6, not behind the 6. But because they don't end up in exactly the same spot, it's not going to work. It doesn't match. We're not using it. Last but not least, pick up the decimal point that's there. We are moving that decimal point 3 times to the right. 1, 2, 3. Extra loop, extra 0. Extra loop, extra 0. And you just see if they match. I got a 3 and a 3, an 8 and an 8, a 2 and a 2, and then I have 2 zeros and a decimal point at the end. This is a whole number. If there is no decimal point, your decimal point is at the end. These are exactly the same number. These match. As annoying as it might seem, all you're doing, you guys, is just making loops, and then you're just checking. If they're the same, we mark it off. If they're not, you don't touch it. Now, I'm going to stop this video because I want to make sure you look at me while I say the next part.